everyone. We have an exciting event today with Blake Burch. He's a CEO of Shipyard, and we're going to do a deep dive into enhancing engineering management through effective data operations. This webinar will provide engineering managers with actionable strategies and insights using Shipyard's advanced data operations platform to boost team performance and project outcomes. We're going to learn from a world-class expert here on how to optimize engineering efficiency through data operations. But before I get started, Blake, you have an amazing background. I was very impressed. I did a thorough research, studied it out. For those that don't know you, can you give a background on you? And then how did you come up with the concept of Shipyard, the product? And then just tell us a little bit about Shipyard to get started.
Sure thing. So my background and journey into the data field, I didn't actually start as someone that was technical. I was working at a digital ad agency called PMG, where I was running everyday ad campaigns, but got super frustrated by the amount of manual work that went into pulling data down into Excel, filtering it, making some tweaks, and then uploading it back into a system. And ultimately ended up teaching myself skills like Python and SQL so that I could store the data in a warehouse. I could filter it continuously with SQL, and I could use Python to send it back to a service. So effectively, I could automate myself out of a job. And what that resulted in was me building out systems that could automate bids and budgets for our clients, automate ad copy, turn things on and off based on inventory. And we saw that there were larger opportunities there to expand that to multiple clients. So I had to figure out, how do I build these solutions to be abstract, to have the same data sources, but slight tweaks? That resulted in me building out data teams for PMG so that we were managing data pipelines for Fortune 1000 companies like Sephora and Booking and Gap and a bunch of other companies along the way. And so we saw a lot that was happening in the data space, but a lot of the automation that we were building out was specifically for marketing. But the key thing that we noticed is that people didn't know how they could use their data effectively in their organization. It was just sitting there, providing no value for the business. But a lot of that was because there weren't good systems and tools in place to help facilitate the usage of that data. And so Shipyard was kind of the brainchild off of what we were building over at PMG. So our journey was all about building an internal tool that could help service these clients, but we spun it out to be its own independent business, which is what Shipyard is today, to help people be able to manage their data end to end in an easy, low-code fashion that still allows you to code if you need to, but providing that level of visibility into where your data is at, what problems it may or may not be having, so that you can guarantee that high quality data is being delivered consistently in your organization. And if something breaks, you don't deliver that bad data and you don't refresh those dashboards and other things like that. So that's really what Shipyard is in a nutshell: a data operations platform to have every part of the data management lifecycle all sitting under one roof.
Oh, thank you for explaining that. Also, if you could give a little background for the engineering managers, what are the core capabilities in Shipyard today that can benefit them and their teams?
Yeah. So Shipyard at its core is a platform to be able to run code and string multiple segments of running code together. So at its core, we allow you to be running that code in like a container where you can install any different like scripts that you want, whether it's in Node or Python or Bash or something else like that, and make sure that things are running in the right order with the ability to like retry and get notifications if something goes wrong, and having the ability to see logs into its performance afterwards. But where we really specialize beyond that is that we spend a lot of time building out low code templates that we 100% open source, so that rather than having to build out the code, if you want to download and upload data between various data tools that you use, like Snowflake or S3 or Box or like GitHub, anything else like that, you're able to do so just by adding a credential, filling out a few inputs, and then dragging and dropping the pieces together. So that's primarily what is possible through Shipyard.
That's great. And we're going to get more into Shipyard here. As we start, let's dive into what the fundamental principles of data operations are. Can you explain those for engineering managers so that they could better understand them?
So the way that we think about data operations is that It is thinking about the very beginning stages in which you initially need to get data. So when you're doing the extraction process and gathering data from an API, and then you have to figure out where to store it. So you choose any sort of storage solution that exists out there. And then once it's stored, you're having to transform the data to make sure that it looks accurate and is usable for the rest of the organization. And then after you do the transformations, you're having to send out reports for that data, or update dashboards, or run machine learning models. Any of those types of activities. Our opinion is that for data operations, each one of those activities should be fully connected together. So if your team is actively building a report, it should be connected to the process that is generating the data that that report is relying on. So you can verify if something goes wrong with the initial ingestion process, or the transformation process, or anything else like that, that you don't actually deliver those reports. And so the key fundamentals when it comes to data operations is the ideas of observability and the idea of connectivity. So there should be no independent jobs that just happen to run at 10 a.m. every single day that can randomly break and you don't know about them. That should be connected to all other types of activities in the organization that rely on that data or that rely on that script, so that bad data doesn't get delivered and processes don't run if something that they rely on breaks. But the other half of it is that observability, being able to know those things, knowing when something breaks, being able to dig into the logs and figure out why, being able to have the assurance that, hey, this entire convoluted network of like 30 tasks that ultimately like results in business data that like the finance team relies on, we know it is running 100% of the time, and we can verify that, and you can dig in and look into it. So for us, it's really about facilitating that entire network and flow of data so that teams can just use the data more, but have kind of the ability to trust that the data they're using isn't going to break and wreak havoc in the organization.
Oh, thanks for explaining that. There's a lot of benefits and components to what you just explained. I think to make it easier for engineering managers, could you give maybe a day in the life, or what kind of, before people use Shipyard, how are they managing their data operations, and then what's life after Shipyard look like? Right, that way people can mentally compare. Oh, this is what I'm doing. This is how it's going to make my life so much better.
I think a lot of engineering teams start off with services like cron. It's a great tool. It has its use cases, but it's something that was built in 1970s to be able to automate a specific script for their team. And it becomes a black box because not only most teams that I talk to, if they're using cron, they have like 30 plus different tasks that they're continuously running on a schedule, but you have to like SSH into a server, look at it in the terminal to verify what's running. Everything dumps into like centralized logs, and you don't know if it's running effectively. And so that's where tools like Chronitor come in. So now you have to write your tasks to then send a command to an external service that will let you know, like, hey, this job did run successfully or not. But you still have the problem of not having the jobs connected together. So that means that you might be running something at 9 and another thing at 10 and another thing at 11, and you hope none of those tasks take more than an hour, because if they do, something's going to break, and you just can't resolve that in something like cron. So you end up either having one mega job where you've like told it to do all of the steps in a very specific order, or you just wing it and hope that nothing breaks. And so there are teams that finally try to level up out of some of those systems, and they choose various data orchestration tools. Like Airflow is one of the bigger ones in the area, but it has its own level of complexities where it requires you to manage the infrastructure. So you might be able to run this orchestration tool on a single server, but as your team starts scaling, you have to have multiple servers that you're managing. And well, now you have multiple packages that have to live on multiple servers. And well, now you needed to run 1,000 jobs at once, and you don't have the capacity to be able to handle that. So you start getting into an infrastructure game where you're continuously trying to battle the growth of your organization, and your stuff isn't just working immediately, because you have to have some of that infrastructure knowledge. And so what I would say for engineering managers is that using something like Shipyard is a tool that gives you like peace of mind into verifying that all of the things I'm responsible for the organization, all of these tasks that my team is building out and running, I know they're running 100% of the time. I can verify how they ran. I can even like give someone a link and have them check in, so they don't have to bug me and be like, "Hey, did y'all run the data extraction process?" or like, "Did y'all refresh the reports?" That's a peace of mind there, but there's also the peace of mind on the infrastructure side. You don't have to worry about things going down. You don't have to worry about scaling up. You don't have to worry about package conflicts and containerization and Kubernetes and all that sort of stuff. You just write code or build workflows that move the data in your organization, and you deploy it, and it just runs on a schedule.
And how does it handle the scaling part when there's a lot of, like, for example, in the day before, you had a lot of cron jobs building up and it would maybe clog the system, tide things out. But how did you solve that problem?
For us, it's a little bit of the secret sauce of trying to be able to have a high level of scalability. So our entire infrastructure is running on AWS, but we've built it out in a way that allows us to be able to handle a high workload all of a sudden from customers that can then immediately be scaled down. But I would say one of the aspects that made it a whole lot easier for us was really with two separate ideas that we built into the platform. The first one is the automatic containerization. So if you have a task that is using like version 9 of a package, and then another task that is using version 8 of the package, you don't have to worry about building out the Docker containers or hosting them or managing them. You just tell us what you want to install, and we install it, and there's no conflicts between those two systems. And that also means if you're running the same thing 5 times, each one of those is like its own unique snapshot, so they can't conflict with each other. That's one way that we kind of made the scale super easy to where you don't have to think about it. But the other way is through what we built out that we call just ephemeral file storage, where as soon as a task is done running, it just wipes the data completely from our system. And not only is that good from a security perspective, which means you don't have to worry about, I've heard plenty of stories where people are trying to run this stuff on their own, and they just keep downloading more and more data, but they never delete it. So eventually the server runs out of space, and now they have to have a task that runs at the end of all their tasks to delete the data. And so like those little things that you deal with managing it on your own, we just tried to build those out to ensure that you don't have to think about it. We're just handling the capacity automatically. So you can focus on what you're good at, just solving problems with data and with the engineering work that you're doing.
So you clearly explain the value, and I've been there before and have several different projects where that is a problem as well. But what is your path to go from the cron job world, I'll call it that, to the shipyard world? What is required? What's like the 30, 60, 90-day plan to get the process evolved? Because there has been a lot of code written with the cron job world and the way things are done there. So can you explain that for us?
I don't think it has to be like all or nothing in a transition. One of the like beautiful things about how we built out our platform is that we are language agnostic, we're tool agnostic, and so as a result, like there's people that might be using things like even like Lambda functions or Azure Data Factory or anything else like that. If it has an API and it's connectable via the internet, you can kick it off using our tool. So one of the easiest things that you could do initially, if you have those scripts living on a cron job on some sort of server, you could use Shipyard to start kicking off those jobs instead, and then eventually move those jobs over to Shipyard. But what I recommend for a lot of people is like starting with the new task that your organization has, like using Shipyard in the early days to solve new problems and like find opportunities where you're starting from scratch, and then you can start to use it as the centralized platform that is kicking off those like external servers that might be running cron jobs, and then eventually take those individual jobs from that server and then start moving them over to Shipyard. One way that we made that really easy too on our part is that we found there's a lot of tools that force you to mix business logic and like the scheduling logic together in one script. We don't do that. So literally, if you have a script that runs on that machine without any changes, you should be able to copy and paste it and move it directly on our platform. If you have it living in GitHub, we can pull it down directly from GitHub and run it from there. So the overall lift to be able to like change the platform that you're using is not as high as it might seem initially. But I don't feel like it has to be all or nothing. I think you can use Shipyard as a centralized system to manage the new stuff and the old stuff and slowly work your way over.
Yeah, and that makes a lot of sense. That's a good plan. What steps should managers take to quickly construct effective data models? So you mentioned that a little bit. What does it take? What do their engineers need to know to start building these models and using Shipyard?
So those,
Data
I would
workflow
actually say that
models.
those.
That's what I meant.
Sure. I'll explain it the other way too, because I think that's interesting there. I think first you have to start off by, frankly, just like mapping out on a paper, a diagramming tool, or anything else. Where are all the sources that your data is coming from? How are you like storing that information? There's two different models for managing data. There's ETL and ELT. It stands for extract, transform, and load. The other one is just flipping that around a little bit: extract, load, and transform. You have to choose like what you want to do. Do you want to load all the raw data in initially to your storage and then use SQL using a tool like dbt or something else like that to run those SQL statements to make views and tables that ultimately the team can rely on? Or would you prefer to take the raw data, transform it slightly with code, and load a subset of the data, or like cleaned or pre-aggregated data directly in the warehouse? That's just totally dependent on the types of like business activities that you might have on your side. But that would be like the basics initially. Like, where does the data come from? What do we want the data to look like? And how do we make sure that we have all of these mapped out pieces on paper get translated to a process that can download, transform, and upload the data between the services? After that, it's really starting to look at a lot of teams that are using like cloud data warehouses. They have pretty strong capabilities for logging that will let you know like how people are actively accessing the data that you have on hand, what tables they're accessing, what columns they're looking at, and looking at that information, trying to figure out internally, how is the data being used? Like, what reports is it powering? What other scripts is it powering? And mapping that out again on paper and trying to figure out, okay, can we map up each of these things directly in a tool like Shipyard itself to make sure that once the data has been loaded and it's cleaned, that we're then refreshing this report or sending out or running this machine learning model or something else like that. So I think a lot of it is just sitting down, mapping it out, and talking with business stakeholders too, to understand like what their needs are with the data, to ensure that what you're building isn't just like this ideal perfect state, that it's actually aligning to something that they care about and something that will drive some sort of like revenue benefit for the business as a whole.
Right, and you mentioned also that you have a no-code capabilities for this low-code aspect of Shipyard. Can you explain a little bit about that and how it plays into simplifying this workflow construction?
Yeah. So I want to say this first. I think a lot of people in the engineering space have a like preconceived notion of what low code or no code is, and I think it gets a bad rap in a lot of ways. For us, what it means is that we do have a drag and drop interface where you are able to like select the tool you want to use, select the action you want to go do against that tool. So if I want to download data from S3, I can add that node in, and then I can fill out the inputs and say, here is the bucket that information lives in. Here's the files I want you to end up the files I want you to end up downloading, and what I want those files to be named or something else like that. And then you can drag and drop that to a new node that you're building along the way. But that doesn't mean that it's not rooted in code. And so for us, whenever you build out stuff in a drag and drop interface, we have a YAML configuration under the hood. So you could choose to write it in YAML if you wanted to in the first place. You can update it via YAML using our API. But the other aspect of it is that each of those nodes, so every like vendor and action combo, we call them blueprints in our application. We open source those. So it's just Python that's running under the hood. So if you needed to like extend the functionality because you have something that is specific to your S3 buckets that we didn't think about, you can fork that from our GitHub repositories and build your own blueprint in the application that allows your team to do the same thing, but maybe with like one extra input that you needed on your side. And so we think about low code first because it means that it's very easy to move and manipulate data. But at the end of the day, we still root everything in code and we still expose what's happening under the hood. Because I can't tell you the number of horror stories I've heard of people using low code tools that it becomes this like convoluted process that the engineering team can't figure out how to manage. It becomes too expensive, and then the engineering team is just rebuilding everything. Well, we're providing you with the code initially, so you know exactly what's running under the hood. There's nothing that we're trying to get away with there. And so for us, the low code is just about the ease, but engineering best practices still apply.
No, that's great. I think you've done a great job from what you explained implementing that low code environment. Let's jump into a little bit about automation and how automation plays a role in Shipyard's workflow management.
For us, when we think about automation, we think about the flexibility to handle multiple different types of situations. And so within the platform itself, we have 4 different ways that you can trigger a workflow to run in Shipyard. The first way is just manually clicking a run now button. That's going to be for any sort of use cases you have that are ad hoc. They maybe don't happen that often, but you want to be able to give like a business user or an engineer the ability to go in, click a button, and get some sort of job done. We also have scheduling in place so that you can schedule things to run up to like every 5 minutes. So you have some sort of process that needs to continuously load data or to continuously like look at some information on the web or something else like that. You can fully automate that process as well. But the last 2 like trigger types that we have for automation, I think can be incredibly powerful. And frankly, it's underutilized a lot in the engineering space, is what you can do with like event-driven workflows. So say like I need to process a file as soon as it has been loaded into S3 or something else like that. We have triggers for both our webhooks and for our API that can kind of react to that data so that you can immediately process and run some sort of like data extraction workflow as soon as a file has been delivered to S3 or to FTP or something else like that. But there's also more interesting things that you could do with it too, like reacting to updates from GitHub or updates to Jira. You can use their webhooks to kick off a Shipyard workflow that then like processes the data that was sent and reacts to it in some specific way to kick off some other flow. So between the webhooks and the APIs, there's a lot of interesting ways to do events as soon as they happen, but also to react to that data and potentially even make the workflow run differently based on whatever happened in the event.
Now, any use in the forthcoming future of AI in the automation that you see happening, or where you could see it happening? Might be far down the road, but
yeah,
you
we'll
dream
say it's a
about
little bit further down the road. So I always like telling the journey of how we got to my thought process on this space. So we started building out a lot of AI stuff back in like late 2021. And our initial idea was building out a service that we were calling words to workflows, something that you could describe the workflow you wanted to have built, and it would use the information that it had about all of our low code templates to be able to provide all of those nodes there, and maybe like pre-fill out some information. So if you're trying to like send a Slack message, it would try to pre-fill the team name and what the message is based on like how you described the workflow that you wanted to build. But ultimately, the deeper that we got into that, the more we realized that providing big prompts and just expecting it to have the type of output that you want, it didn't really work. Instead, we needed to move towards like a smaller level. So one thing that we've added into our platform is that for code, if you don't know how to write code, there's a little button that says build with AI. You can click that, describe what you want it to do, and then it will write the code in order to do that. All you have to do is import the packages, and then you can connect it up there. But the dream state for me is not just being able to do that in like a small unit, but being able to build out the entire workflow step by step that way. So you could say, hey, I need to download data from HubSpot, and you're talking to a chat bot, and it like fills out all the details and like gives you a file and says, hey, does this look like it needs to, like you thought it needed to look? And you say, yes. Okay, now with that data, I need to transform it and like only keep these 4 columns or aggregate it in a specific way. And then it spits out the results and you're able to investigate it and see, does that look like I wanted it to? And so on and so forth. You could keep doing that for every stage of the workflow. And so you end up in a state where the nodes that have code are also stored as a conversation. So a non-technical person can basically be their own product manager, their own QA person to make sure that it got them the outputs that they wanted. But the engineers can still come in and tweak the code that was generated by it overall. So that's something that we're pretty excited about and trying to build out further because like a tangible example, we've dealt with a lot of like data analysts that they know how to grab the data. They know where they want to send it. They don't know a lick of Python. And so their goal is like, okay, how do I make this data look exactly like I need it to before I send it out to my partner or my vendor or something else like this? And we've started like sending them to ChatGPT. Hey, go provide a sample file to ask it what you want, and then it will give you the output code. Just plug and play that code directly into Shipyard. But we want to not have to outsource that to ChatGPT. We want that to all be within the walls of the workflow platform itself.
Oh, that's great. I think you just added the spice level in this podcast with those tidbits a lot higher. That's really cool. Looking forward to that release. We're going to switch to talk a little bit about the common pitfalls you see in workflow construction and how Shipyard helps you avoid those, right? So for engineering managers really thinking about this, they have a lot going on in their mind. They're excited. This gives them new opportunities to do things they couldn't do before, scale like they couldn't do. As they're looking to do it, what are some common pitfalls that they may run into, and how do you help them overcome those?
The 2 biggest issues that I see people come up against is first off, trying to like over plan. I'm a very like big proponent of not trying to have like the perfect setup initially, because I see a lot of teams get kind of lost in the sauce of trying to have all the data available with all of this clean stuff, and only then will the teams actually start using the data that my team has generated. And that usually ends up not being the case. Instead, I like taking kind of a use case based approach. So as you're building out a workflow, find a very specific use case that you can power with the data and build for that. And over time, you'll find the flaws with that sort of pattern. You're going to run into flaws regardless, but it's easier to fix when you just focus on getting something up that solves the problem immediately versus trying to have the perfect infrastructure that probably isn't perfect for whatever use cases could come along. So just not focusing so much on stuff being perfect and just on something that gets the job done that you can tweak later on. The second thing that I see as being kind of a major pitfall when building out workflows is not thinking about testing. And I think this is especially true for a lot of engineering managers. They think of testing in terms of testing the code and making sure that the code works effectively. But very few people are focused on testing that the data is correct. So certain things like the data set that is being generated whenever I'm like downloading it from HubSpot, does it always have 10 columns? Are those 10 columns always named the same things? Do the values in this column always fall between these specific parameters? And there's tools out there that like run with Python, like Great Expectations, that are like best in class at trying to make sure that you can accurately test data. Because we run any sort of Python, we actively encourage people, hey, between every step of the workflow that you're building out, like you should have something that's testing and making sure that the data looks like you expected it to. Because just because you got a green light that it downloaded the data doesn't mean that that data looks like you thought it would look along the way. So prioritizing that level of testing of the data is a really good way to try and make sure that you're not gonna like have a lot of data issues later on down the road.
Now, this perfect segment into my next set of questions is so maintaining this data integrity is a major challenge. You identify as one of the big point challenges the engineering managers have. How does Shipyard assist in this crucial area of maintaining data integrity?
The biggest way that we help people comply there is just from having the flexibility to allow people to add in those tests on their own. In general, we try not to like look into the data itself, because we're just wiping the data afterwards, right? It's just hitting our systems, and so we aren't as context aware about what's in the data, but we give the full capability to run other sort of data testing tools along the way, to make sure that like that data is meeting your expectations continuously. And you, whatever you run, we store all the logs for that. So over time, you can see like how many rows, how many columns did or didn't meet the expectations. And then you can build that into the workflow itself to say like, hey, if more than 90%, if more than like 10% of these tests fail, then we want you to like stop the entire workflow and not do anything else downstream. So it's not built directly into our platform, but there's the flexibility there to make sure that your team can make those tests however you want, and also ensure that you can stop the entire workflow and get those notifications, dig directly into the logs so you know why something failed more immediately than you would in any other type of system.
And do you provide monitoring capabilities for those workflows and for the data? What type of monitoring do you provide?
Everything from the monitoring side is totally built into our system. So we have full dashboards and everything else that you can explore and use directly in the platform itself. Every single task and every single workflow has its own like email notifications that are tied in. And so those email notifications, we've had people use it from sending Slack messages to like PagerDuty to try and make sure that there's no sort of issues there. Alongside that, we provide full level of through our API, you can export all of the logs. So you can analyze any of that information on your own to verify if things are taking longer to run over time, if they're dealing with any sort of issues like that. We also have audit logs directly within the platform to be able to verify every single touch point and like event that people are doing within the application. But one thing that I think is quite neat that I haven't seen in any other tool is that we have built-in version control that we tie to the logs. So if something goes wrong, not only can you see what went wrong, but you can see what is the version of the like workflow configuration that caused this issue, and you can like do a diff between that and again see who made the change, what specific change was made, and isolate that a whole lot quicker. So all of those things combined just make it super easy to monitor and just verify that your stuff is running correctly day in, day out.
And we're going into the final segments here of our podcast. You've explained to us a lot about the capabilities of how you can enhance data operations, how you can make it so we can monitor it more secure and easier for teams to build it themselves or no code environment to do that. What kind of size of clients are using Shipyard? Are they smaller, medium, large? what do you say is the type of customer that gravitates towards your product?
Early in our journey, we had a lot of folks that were in smaller organizations, but we very much gravitated more towards companies that are going to be like 500 plus in size. But really, it's more about like the size of the data team. Where people find a lot of value in us is when they have a lot of existing systems that they need to make sure are running consistently. And there's just not a good way to do that on in the ecosystem right now, besides Shipyard. And so we do find that a lot of the larger clients that need to make sure that the data engineering team is talking to the data science team, is talking to the data analyst team, and that they have visibility into the 10 plus tools that they're using in their organization. That's where it's a great fit. But that doesn't mean that it doesn't work well for small organizations too. We have plenty of like smaller startups that, man, they can be scrappy as all get out with a one person data team running everything from our platform. You don't need a large team when you have such an easy way to build reports and ETL jobs and everything else like that. So it's super powerful from that side as well.
Now, can you explain, as we get into the bigger size team in this last part of the discussion, what kind of capabilities do the Shipyard provide to enhance collaboration across these different data teams?
The biggest thing we have is going to be related to visibility and the ability to um, actively see what other people are working on and being able to like directly link into workflows that they've built. Having that level of ability to see like when someone makes those changes, being able to get updates on things that matter to you. So if you have an entire end-to-end workflow, you can have the first few nodes of that workflow that the data engineering team is getting alerts on, the middle ones the analysts are getting alerts on, and the later ones that data scientists are. But everyone's able to work off the same picture of how the data is flowing, but each kind of focus on their own respective parts. I think another aspect of it is for collaboration is really related to kind of like security features. It's not as often talked about for a lot of teams, but being able to like specify who has access to which services, to which workflows. And so maybe from a security perspective, you need the data engineering team's workflows to be hidden from everyone else, but you still want everyone else to be able to latch onto or run after those jobs finish running. And so our platform like provides ways for people to do that still in a secure fashion where you have just better data governance in general.
Appreciate sharing. Scalability. Well, the last thing we'll touch on is scalability here. How does Shipyard's infrastructure support the scalability of these multiple teams, and how does it allow for coordination as you're planning scalability?
The way that we think about it primarily is that you shouldn't have to think about infrastructure or scale. You can press a button once and it'll run. You can press a button 1,000 times and it'll run just as fast. Ultimately, at the end of the day, we found that a lot of teams were being placed in charge of like infrastructure type tasks that they weren't as skilled in. And so we wanted to make sure that like data practitioners specifically didn't have to worry about that, but also from like the engineering manager side of things, you don't have to worry about running and maintaining multiple different servers 24/7. We're just charging on runtime that things are actually running on our platform, but that's because we're able to spin things up and down easily, have that level of containerization that ensures you're not going to get conflicts between all the different jobs as you scale. And so ultimately, that's really what we try to offset and make sure that it works well for teams. The other aspect of it, though, is that all of our low code blueprints that we build out, we test for really large sizes of data. There's a lot of rigorous QA that goes into our side to make sure that things are designed to like split out the data into multiple different like chunks effectively based on like what's in the data, what it looks like. Is it wide data? Is it deep data? We kind of handle and go through all of those things on your behalf to where like if you're writing a script to download data from Snowflake or upload it back in or something like that, yours will probably work, but I would bet that ours will probably end up being like faster or more sustainable over time, just because of the level of like rigor and testing that we put into everything on our side. And I think that's something that a lot of data teams don't think about. If they're just trying to solve the problems of now, they also need a tool that can solve the problems of the future as well. So like the level of flexibility to run your own code, to like mix and match various tools that ultimately helps an organization be able to scale as they grow as well, just by having the opportunity to build a workflow however they need to on their side.
No, you've been great. I think for the audience, you've given us a pretty good understanding of Shipyard, pretty good understanding how to up level your data operation and your infrastructure, and provide a scalable, collaborative way to manage that data and the workflows around it. Any last words you want to leave with the audience today before we end that you may have?
Sure. One of the biggest things that I hear when it comes to data operations is that there's a like lack of trust, because the data went wrong at one point and people no longer trust the dashboards, and they don't know like if your process is running successfully. Your system might be perfect, but that one instance that happened 2 years ago means that the entire finance team doesn't trust you for some reason. Like regardless of what you do, I would encourage two things. One is making sure that whatever process you're using to run that data, make sure other people can see it. Seeing is believing when it comes to building trust. But the other aspect is give people proactive alerts. It's something that's really easy, but a lot of people miss that. If a system breaks, make sure that the team that is going to rely on the thing that's affected by the data breaking knows. They get an email. They're told, hey, we're on top of this. You're going to have delayed reports. Here's a link to the Jira ticket of us actively addressing it. Here's a link to the process that is broken. I think that goes a long way just in terms of like helping restore that trust and making sure that your team can be fully relied on.
That's great advice. And for those interested to talk to you or Shipyard, how do they get a hold of you? What's the best way to do that?
Yeah, for myself, you can find me on LinkedIn. That's probably where I'm the most active. And for Shipyard, it's just going to be shipyardapp.com. And I'd also recommend, we have a weekly newsletter called All Hands on Data to just keep up with the latest and greatest news in the space. That's always super helpful to subscribe to as well.
And two more. We have a different audience that also listens to this. They're always looking for better products to be able to integrate into environments. They're consultants looking to sell other products. Any partner program you have for them that they can help with implementation, help extend the engineering manager's capacity with resources?
Yeah, 100%. Would love to talk to anyone on the partnership side. Just shoot a note directly to me or to partnerships@shipyardapp.com. The way that we typically work with folks is either like consultancies and agencies that are having to continuously build these types of data operation workflows for organizations, or working directly with other tools in the space that want to be able to connect to other data tools. Typically, we do the development on our side, but our goal is to be able to connect to all of these different tools and have kind of like a bi-directional sync going on. So I'd love to have the conversation for anyone that's interested in integrating into our platform or just using it for their own clients.
And Open Teams has a community of open source architects that are always looking to do things with open source. You mentioned templates. Any thoughts for them on how they could work with you?
I would recommend going directly to our GitHub. We have the Shipyard Blueprints repository that's fully public and open. We would love to have more people trying out and using the templates that we do have. All of them can be pip installed and run on your own side. All of them can be contributed to if you find additional functionality that you want extended or new integrations that you want. So would recommend going directly to our GitHub there for that.
Blake, pleasure to have you. Very insightful conversation. I really hope that as people listen, they got a pretty good view of the problems being solved by Shipyard, how Shipyard can help you, the capabilities that you get with Shipyard in the sense of protecting, scaling, easy to automate, cross-team collaboration. And for the partners and open source architects, many opportunities here with Shipyard. So Blake, appreciate your time, and thank you everybody for listening.